Hello everyone, it's October 19th. Time flies. Another weekend in the rear view mirror. Time passes by so fast. Sometimes I just wanted to slow down, stop, Does that mean we have to think about this one again? Yeah, we should. Alright, find value of variable after performing operations. There is a programming language with only 4 operations and 1 variable. This, initially x is 0. Given an array of operation containing list, return the final value. Minus plus plus, plus plus plus, plus plus minus minus. Okay. So basically, it's either at the first position or the last position, right? Yeah, so first position or last position is plus, or first position, last position, okay? I'm not complaining. Sometimes you do need an easy question just to, reset your mind and then all that type of stuff. It's life, we can't go balls to the walls all the time. You need to rest, recoup. I think I did a little bit too much snatch today. It's possible. I think I hit like maybe 5 singles on the snatch. I'm not supposed to. I'm supposed to only hit 1. So, but hey, it happens when I go a little bit crazy on the snatch. All right. Anyway, OP. I can do this plus, right? Or I might be able just to plus equal to this, right? OP0 equal to this, or OP, 0, 1, 2 equal to this, and now return rest. I think this is sufficient. Think so. It has to be -1. It's not 0. Damn. All right. So what we this we say 1 minus 1. Yeah, it's all right. You just have to redo it a little bit. In fact, let's remove this. Okay, so we're done for this. Okay, I have to kind of get back into the mind. I forgot. So S and K. First, you are allowed to change at most 1 index to another lowercase letter. After that, do the following partitioning until S is empty. Choose the longest prefix containing at most K distinct characters. So our idea is, if I remember, we'll get the original partitioning, right? And then we'll have a DP. DPI is the max partitioning is a max partitioning starting from SI right? Starting from SI. So we can create this. I remember how I solved this. Starting from SI to the end, we need a few auxiliary as well. We need a consecutive, right? Consecutive length I is the number of consecutive SI, right? Number of consecutive SI from position I. This is the computed DP. So now, when we have this, basically what I want to do is the maximum possible resulting partition after the operation by optimally choosing a most one index. So we get this, and then we just choose one, make the change, and I have 26 different ways to change, right? We choose the change, and then once we change, we need to see how the consequence is going to be. Right, we need to see the consequence of this change. So when you do a change, you skip yourself, right? So you change, and it will affect, because you're changing inside this, right? When you do a change, it will affect this part. You're also affecting this part. So when you do a change, what you want to know is the previous. Well, we can check what is the previous index. So you know this is the previous index. So what we want to know is, starting from here towards you, when you do the change, how many uniques do we have? So what we can do is so I just need to know the number of uniques in this. Like, you are here, right? This is you. This is you. I need to know the uniques in here. So to know the uniques in here, we can, I think there is a way to get the uniques here. We can say every time we start, we just like the uniques up into here. The uniques up into here. So it's like a prefix unique, right? The prefix unique. So the prefix unique will allow us to know how many uniques are here. So once we know that, but we don't know what are the uniques, right? I don't know what they are. So how am I supposed to know once I change what is going to be? So I need to know what is the previous letters, right? What is the previous letters? And I think we have proven that if you change to one of the previous letters, one of the letters that's in this group, if you change into one of the letters in this group, it is not going to help. If you change into one of the letters in this group, it's not going to help, because they're all going to be removed in one way, so you're not creating more, right? So yeah, so changing into one of the existing is not going to help. So you have to change into a new one, right? You have to change into a new one. Okay, you have to change into a new one. So we change into a new one, which means the number of uniques change. So this one has to get split. So now the question is, how do we split? Right? How do we split? So we need to know how many uniques are in before. So it could be we have a very little unique in before, and then we have this. So what we need to do is kind of a reset, right? So I know the number of uniques up to here. I know the number of uniques. So there are two scenarios. One, the number of uniques up until here is larger or equal to, no, it cannot be larger, it's equal to k, or it's smaller than k, right? We have only two scenarios. If it's smaller than k, then we adding this will make it equal to k. So we can just keep moving on until we find, because initially it's more than k, right? So we just keep moving on until we find a position where it is first time become k. That is when we have to break. So that's when we break. So we'll do that. And then we'll use the dp to starting from this position going down. So that's one. If it's already equal to k, right? If it's already equal to k, but does that mean every time you do this, wait, how long is this? 10 to the 4th. So if it's smaller than k, I need to keep going until I find a position where it is k. That I feel like can be simplified as well. We can say at what position it is k, the first position that is k. All right, the first position that is k. Well, if we go from right to left, we know the first position that is k, right? But anyway, if it is k, so the previous is already k, and then you change yourself, that means we'll break right here, right? We break right before you, because including will be k plus 1. So now it's from u, we have to go down, right? From u, we have to go down. I know starting from this position, the maximum, but now we change. Now we're starting from a different ladder, right? Starting from a different ladder. So what I need to do is to count the k. So we do this, we see this will give us to a certain position, and k is 26, right? So this will give us a certain position, and the next one will give us a certain position. Because I have this consecutive length, so I'll find this part, and okay, I think this will work. And if we go from right to left, we'll hit k first, all right? So we'll do this, and then we'll record what is the final, the leftmost that records k. So once we get to the smaller than k area. Oh yeah, and then once we become k again, that means we stumble to a new one. Okay, we can try it. I think this is, when was this? Friday, 17. A bunch of things to deal with. So this is 3003. We need a few auxiliary arrays. So we need a consecutive length is the number of consecutive SI starting from SI consecutive ladder starting from I, position I. We have max partition I is the max number of partitions starting from position I. Okay, so I have this consecutive. We have to also know the unique letters, right? Unique letters. Unique prefix, pre-unique number of unique letters in this. Now, number of unique letters in each partition, in each part okay, number of unique letters in each partition starting from the beginning of the partition. Okay. Oh, I don't know. So we do consecutive I first. Okay, so consecutive I is, so int n is s dot length size. So we say vector int consecutive length n. Okay, and then we say consecutive length 0 is equal to 1 for int I 1i smaller than ni plus plus if si is equal to si minus 1, right? Then we say consecutive length I shall equal to consecutive length I minus 1 plus 1, because we do that, right? Else, if they're not the same, then consecutive length I shall equal to 1, because the current is the starting point. Then we just move on. So this is the consecutive. So basically we say starting from here. That is not true. I think you got it wrong. I think we need to go from right to left. My bad. Yeah, this has to be from right to left. N minus 1. Consecutive starting from. So yeah, this should be n minus 2. My bad. Sorry. It should be large equal to 0. This is I minus minus. So we say if si is equal to plus 1, then this shall equal to this plus 1. Otherwise, it will be 1. And then this, if it's equal to this, will accumulate, accumulate, accumulate. So that's consecutive length, right? We also need a max part, right? So get consecutive length. Okay, next is get max partition. Max partition and okay. So max partition also I think is from right to left, which means max partition n minus 1 is going to equal to 1, because the last one it can only have one partition because it will be deleted once. So as we go, right, so I'm at a certain position. What I want to know is if I starting from here and I start to delete, right? So what I do is I'll jump forward, I jump like k times, and then I'll add the remaining, right? So we say for int I equal to n minus 2, I large equal to 0. Okay, I plus n minus minus. Okay, then I'm at I, and then I will get forward. So unique count, right? Unique count. Unique count. Yeah, we need unique count. So we say int unique count is starting from 0, right? And then for int j equal to I, j smaller than n, j plus plus, unique count plus plus plus, because we are here, right? So now we can say j plus equal to, oh, then we don't need this, right? J or plus equal to consecutive length j. If at a j position we have consecutive length is 2, right? So j will plus 1 plus 2 equal to the next one, right? And then we go forward, and then we keep going, and eventually we'll get out. Eventually we'll get out, actually end unique smaller than k, right? Unique should be smaller than k. So unique plus plus, j jump forward, and then we check unique. And then if unique is equal to k, then we get out. Otherwise, we just go to the end, we get out. So once we get to the end, we need to know where j is. So in fact, I think j equal to I think it will be easier to do a while loop. While this j is smaller than this and this, right? This and this. So when we get out, you need to check where j is, right? So we can say max partition I, right, shall equal to, it's always going to be 1 plus, so here j is smaller than n, then we can do max partition j, because you are adding j to the next, basically that's the next one, that is the starting position, so you should do the max partition from here. Well, if not, then it's just going to be 0, that's just going to be 1. So this is max partition, okay? And then we need to do a prefix get, prefix unique. Okay, so vector prefix unique. Okay, how do we count unique? I think I'm going to use a set, unordered set. I think this is the easiest way. Actually char uniques, okay? And then we're just going to go from start to the end, right? So for int I 0, I smaller than n, I plus plus. So uniques dot insert, I think yeah, uniques dot insert si, okay? If uniques dot size is larger than k, all right, so we actually this one is too much, is larger than k, and then what we do is prefix unique I will become 1, uniques dot clear, uniques dot insert si. Else, which means it's smaller equal to k, then prefix unique I shall equal to uniques dot size. We have that many uniques, right? So every time we insert, and if it's too big, that means we have ended, then we'll reset, so become 1 again, right? It'll become 1 again, and we get unique only have 1. Otherwise, we will do what this is clear. Hold on. Unordered set clear. Erase all element. The size will be 0. Yeah, that's exactly what I want. So you clear it and you put it in, right? Otherwise, you just record its size. Okay, so that's the uniques. Now what we can do is let's find the answer, right? By going through the letters one by one, by going through S from right to left. So there's one thing I don't do is I can't I need to know the set of things, right? I need to know the set of things, but I guess yeah, it's okay. It's probably, yeah, from right to left, and at each position we change the letter to all other possibilities and count, and produce and find and get and compute the number of partitions. So rest will equal to 0 because we want the maximum, and then we're going to say for int I equal to n minus 1, n minus 2, because the last one doesn't actually, so this should be 1, right? N minus 2, because the last one, no matter how you change, actually no, rest should be the number of this. Ooh, hold a second, I need to put rest here. 0. At least the result, right? At least the result should be the number of partitions without any change. So if blah 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 blah, every time this is larger than k, we all say rest plus plus, right? Rest plus plus, and then at the end, the last one always, right? The last one always can give us 1, right? This is the last one. So this is this. So the last one you change, it's not gonna make any difference, right? Because if you change to something that's similar to before, it's the same. If you change to a different one, oh yeah, you can't make it bigger. So oh yeah, don't do that. I minus, right? So the last one. So we're gonna change to all different things except for itself. So we say for int j0, j smaller than 26, j plus plus. If a plus j is not equal to si, so this is what we're going to change, right? So after we change, what we're going to do is find the number of uniques so far, right? The number of uniques so far. And so we have 2 scenarios, right? 2 scenarios. One, the number of uniques so if I is larger than 0, and if larger than 0, right? Else we don't handle this, right? So basically here what we say is check whether the subpartition on the left how do you know it's the start? I know the partition start. I cannot just say K. Or I can say if current is 1, but the previous is K, that is the partition. Or current is 1, the previous is nothing. Those are the situations where you are actually at the start. Check whether the subpartition on the left, right, can be check how the subpartition on the left should be handled. Yeah, this is actually just need to check whether SI is at the beginning of a partition. Yeah, how the subsequence, how the string, right, on the left of the partition subpartition. Check if it's at the beginning of the partition, right? If it's at the beginning of the partition, then it's slightly different. So yeah, we don't do anything because there's nothing on the left. Yeah, there's nothing on the left. Unless you're changing into something that is the same. But then why would you do that? Right? Why would you change into something that's the same as the left one? And you're just extending it, right? So this change has a few things we need to consider. Don't change to something that's the same. So and I and I minus 1 is large equal to 0, right? And A plus J is not equal to SI minus 1. Should be I equal to 0 or do not change into the same letter as SI or the same letter as SI minus 1. Because these changes will not result in an increase in partitions. So we change the same as before, you just allowed it to extend, right? So it will not make it even better. So yeah. So I check it's not here, or if previous is 0, so there's nothing. But if it's not, then it should not be the same as before, right? And then we are certain that this change will not be merged with the previous one. So we need to check. If it's the beginning, right, then we don't consider, then we just consider the result. Otherwise, then we have to consider the extend, right? Extend. So we can say basically what we want is yeah, I think is at the beginning of the partition. So this we say at the beginning of the partition, and then we can do else. It's not at the beginning of the partition, and then we do something else. Okay, so yeah, this is going to take a while. Let's stop right here. I'll continue tomorrow. Alright, that'll be it. I'll see you guys tomorrow. Adios.